We finally made it to the scheme for metamorphic rock identification. This table looks very similar to the sedimentary rock identification scheme. So very similar columns here. We have texture, grain size, composition, a new column, type of metamorphism, comments, rock name, and map symbol. So as we read down the texture column, we see that there's two primary types of texture. There is a foliated texture and a non-foliated texture. Foliated texture means that there is some sort of pattern, and this is caused by increasing pressure. So it starts as mineral alignment, where different mineral grains will start to face the same direction and become aligned together. And in more extreme cases, as pressure increases as we go down, you will go from mineral alignment into what's known as banding. So you have this distinct light, dark, alternating pattern. Non-foliated rocks do not display any of this sort of pattern in their visible appearance. Grain size runs from fine to coarse, just like it does for igneous rocks, as well as sedimentary rocks that happen to be crystalline. Looking at the composition column for the upper foliated rocks, you have to read this horizontally. So for example, we draw a line from slate. This line only goes through this mineral mica. If we drew a line through schist, this particular schist would have pyroxene, garnet, amphibole, feldspar, quartz, and mica in it. And then gneiss would have the same assemblage of minerals, but we could have a phyllite that does not have any pyroxene in it at all. Types of metamorphism, there are two. So one type of metamorphism is regional metamorphism. This is a large-scale type of metamorphism due to tectonic activity. So we have both heat and pressure, but primarily pressure. And then we also have contact metamorphism. As the name might imply, contact means things need to be touching. So you have a rock that comes in contact with a hot magma body or possibly a lava flow at the surface, and that heat from the magma or lava essentially cooks and changes the rocks and turns them into a metamorphic rock through heat. Comments will tell you the original rock was. So for example, if we look at anthracite coal, in the comments it tells us it's a metamorphism of bituminous coal. Quartzite is a metamorphism of quartz sandstone. Marble is a metamorphism of limestone or dolostone. And so if you're looking for what was the rock before it was metamorphosed, you want to check the comments section. And of course, rock name is straightforward. So the map symbol works the same way as it did for the sedimentary rocks table. You see this in a diagram, and you know you're dealing with, for example, a gneiss or a marble. And you would just compare this to a diagram that's provided to you. So how do we use this table to answer questions about rocks? Let's imagine we're looking at the rock quartzite. Maybe the first thing you want to know is what type of texture does it have? So you start in the texture column and you line up with quartzite and you figure out quartzite is non-foliated. We can say it has fine to coarse grain size. It's primarily composed of quartz. It forms through either regional or contact metamorphism, and it forms through the metamorphism of quartz sandstone. If we want to take a look at the only rock that is solely created through contact metamorphism, we would check the type of metamorphism column. The upper part are regional metamorphic rocks only. Anthracite coal forms only through regional metamorphism. Hornfels is the only rock on here that is created solely through contact metamorphism. That is metamorphism from the heat of nearby magma or lava bodies. Hopefully this video was helpful. If you have any questions or suggestions, please let me know in the comments.